Welcome to my talk where I tell you not to do the things I'm about to tell you to do. This talk is meant to provide unfamiliar concepts and ideas. You're meant to leave this room confused. Most importantly, even if just for a split second, I want you to think, I wonder what if. This talk contains a lot of information really quickly, just to fit it all in. Combine this with the fact that I'm terrified of public speaking. Let me know if I'm going too fast. These slides, including the speaker notes, are available to download if you want to go through them again, which you probably will have to do. And I'll be outside, not in the hallway when I wrote these, but at the speaker corner, which is where I'm told to be, during lunch. This is a technical talk. Don't worry about keeping up with all of the examples. There are a lot of them. The overall idea is more important. You only need to keep up with what the examples are doing, not how they do them. Also, for the remainder of this talk, imagine we don't care about performance because you're not going to get it here. Streams. In computer science, a stream is a sequence of data elements made available over time. Think of it as items on a conveyor belt. They are processed as they arrive. And like most things, the conveyor belt will stop when there's nothing else to do, but they can run continuously if need be. They are written from and read to in chunks. If you write PHP applications that deal with the input and output of data, you use streams. They're a core functionality of PHP, and they're pretty unavoidable for any developer. Streams in PHP are a way of generalizing file, network, data compression, and other operations that share a common set of functions and uses. There are resource objects which can be read from and written to in a linear fashion, i.e. chunks. If you've used Guzzle, or you've used sockets, accessed the file system, or even dealt with a post request, you've used streams. PHP has a very low barrier of entry, so naturally these are abstracted away from the developer, and if you don't want to, you probably will never have to deal with streams directly if you don't want to. For example, file get contents of hello.txt really means we're using the file wrapper protocol to get the requested URI. PHP supports, native PHP supports the following protocols, or as they're known, stream wrappers. Each wrapper can support multiple protocols, e.g. HTTP also does HTTPS at the same time. If you use the extensions, you can also get these ones, including expect, which is something to do with assertions using streams, and I still don't know what it means. Has anyone come across the S3 protocol using the AWS SDK before? PHP lets us define our own stream wrapper protocols in userland PHP. So, for example, introducing brainfuck. Obviously not the best name to use at an international conference, but it's perhaps the world's best well-known esoteric language. For example, this is Hello World, which I completely stole off the internet because there's no way I wrote that. If we require that file, the contents will get dumped byte for byte because the PHP interpreter doesn't find any PHP code. If for some arcane, horrible, horrendous reason we want to write parts of our application in BF, and we require it, this is the equivalent of using the file protocol, which is no good. We can substitute this for a custom stream wrapper in userland PHP to manipulate the input before including the result, which is stream wrappers. Here we have the boilerplate for a stream wrapper class. We have the class definition, a helpful static methods to register it with PHP. Stream wrappers confusingly don't extend anything in PHP core like an interface or a class. So you add these methods. It won't complain if you don't add them until you try and use it. We have the stream open, stream stat, stream read, stream end of, and stream close. They match the underlying C code of what it represents. That's all the detail I'm going to go into stream wrappers because I'm going to take this time to tell you about this amazing resource that's available to PHP developers called documentation. You should use it more. I know I don't use it enough. For completeness and just to satisfy your curiosity, here is the method to execute a brainfuck script. This example is using IRC Maxwell's library. We take the contents of the script, pump it through the language runtime, save the result as a string, and ready to stream out when people call stream read, or PHP calls stream read for you. Requiring a script using our new stream wrapper does not give us a chance to give input, which is kind of important for some scripts, which I am not going to write. We can accept input as a string argument to the stream write method. It's tongue twisters, all of this. Unfortunately, in our example, this means we can only accept input before we start reading or executing our script. But an example of how to use it is registering our stream filter, opening a stream handle, pump in some input, and get the output of our script. Yeah. This is good, but if you want inputs going into your script, when you require it, you can't use it using this method. Next up in the stream arsenals is stream filters. They're simpler than wrappers, luckily. It's what we're going to use for the rest of this talk. They're just a method to modify data as it passes through. It means you can't use input and output. You can use input or output, one of those things. So this is the perfect time to introduce source code transformation. Here we have the boilerplate for a stream filter. Extends a core PHP class. Then we have a register static helper method, which we could do outside the class if we want to, but it's nice keeping it here. And we implement a filter method. The streams are processed in chunks, so the vast majority of this method is just dealing with pulling in the stream data. This is possibly done over multiple invocations of the method, so a lot of it is a loop saying, have we got to the end? No, give me some more. Have we got to the end? Give me some more. But at the end of the day, it just boils down to data in and data out. In this example, we're generating valid PHP code using a code template. Every time I've had to deal with XML in PHP, I will use Twig instead of having to deal with encoding, because I'm lazy and it works. Why not do it for PHP as well? This is similar to before. We register our stream filter, except this time we attach our filter to an existing stream handle, which we use fopen for. When we read the contents of the stream, we get back valid PHP that we can execute using the eval function, which everyone knows is the best thing in PHP. Good. Attaching a filter to a stream handle and evaluating it every time using eval is probably not the best way to do it. We cannot use require either. This is where one of the most underrated features of PHP comes in, the PHP stream wrapper. More specifically, the PHP filter meta wrapper is how they call it. It allows us to act upon any resource existing, so file, HTTP, etc., while attaching any number of filters to manipulate the stream when reading it, as well as when we're writing to it. For example, this allows us to pass a single string to require. This one string means we can open a handle, attach a filter, read the result, and evaluate the result all in one line. To sum up all of the stuff we've come up to so far, very quickly I know, to sum up, we now have a way to filter the contents of a file before PHP executes it. At Dutch PHP Conference 2016, I saw a talk about Go OAP, a framework created by Alexander Lysychenko. If I pronounced that wrong, I'm so sorry. He's Russian. He gave a talk 3 years ago. And that's the main inspiration for this talk. I'll give an extremely brief idea of what the project does, and then we'll delve straight into the internals to figure out what's going on so we can try and use it in other applications. AOP stands for Aspect-orientated programming. It's a framework for developing PHP applications using that paradigm. It's separating out logic when developing and then joining that logic together at runtime. I use the same examples as the creator of this framework, just so they're correct and up to date, but I recommend that you go see Lysychenko's previous presentations on the subject. I think they're all on his website, but they should be on his GitHub as well. Let's say we have a method that creates a new user in our application. As far as business logic goes, this is pretty much all we have to do. Unfortunately, in the real world, things aren't that simple. We need the authorization service to check that the currently logged in user is allowed to create new users. We should probably log the creation of a new user when it happens. We need to emit an event, so later on we can send an email that the account is now active. And we also need exception handling in case something goes wrong. While this example may not be completely unwieldy once we've factored everything in, it does demonstrate that more complex business logic needs to consider so many different cross-cutting concerns, and it can get very unwieldy very quickly. Aspect-oriented programming is about keeping your method simple and interrupting the execution flow of your application logic at specific points. You keep your logic separated and inject each piece where it needs to be. These injected pieces of logic are called point cuts. And our first one is the logic for ensuring that the currently logged in user is authorized to use the user service. And this happens before any public method on the user service is called. The next up is error handling. And this happens after an exception is thrown in the original business logic. And finally, we have the logic to emit an event and log the creation of the user. And this happens after the successful completion of the original method. The framework also allows you to decorate the original method and make do things before and after, do comparisons, and even modify the result before we return it. All of this the majority of AOP's logic is in the form of source transformers. By using AOP in your application, you're entering the realm of metaprogramming, where your application transforms its own source code when including it. So what is that AOP doing inside this transformation process? It queries Composer. It's Composer's class loader for the location of the file that should contain the class. It generates a load of metadata about the source code file. It generates an abstract syntax tree generated by Nikita Popov's PHP parser. Probably said that wrong as well. It then passes that metadata through a series of source transforming classes, each manipulating the abstract syntax tree to provide a particular feature. And then finally, it dumps that manipulated AST back into PHP code as a string. It's at this point that AOP caches the result, which actually makes it faster, but we're going to ignore that because we don't care about performance. The final code is then returned from the function to be executed by PHP as the code. All of this happens whilst you're writing PHP applications normally, without worrying about class loading or compiling into usable code. As this talk is all about PHP streams, it may not come as a surprise, as the main logic behind this is all done inside a stream filter. And a massive amount of complexity is held within that process in the framework, enough for an entirely different talk, one that Lysychenko has already done. So for the sake of time constraints of this talk, we'll simplify the source transforming process into a single function call, because quite frankly, a PHP filter does not fit on one slide. If you try and create an instance of my class, how does AOP manipulate Composer to pass the source code through the transform code filter before getting PHP to execute the result? You go to instantiate a new class. Composer does its normal thing, figuring out where the class is meant to be located. AOP hijacks the normal Composer logic and tells PHP to load a new URI that uses the PHP stream wrapper. PHP then applies that go.source.transforming.loader stream filter, that's what it's named in the framework. When reading the contents of this URI, from the file system. So what kind of sneaky magic is this? AOP will fetch all of the currently loaded autoloaders using SPL autoload functions, which will return an array of autoloaders that are currently registered with the application or with PHP engine. It will iterate over each autoloader. If AOP finds Composer in that list, it will replace the original Composer loader with a decorated version of it. It will pretend it was there all along. It will re-register the autoloaders with PHP, and then PHP just accepts the divine wisdom of AOP unconditionally. So what magic is this? What it looks like in code, this is our autoloader overloader. I get those mixed up a lot. So since it decorates Composer, we accept it as a first argument. It's always useful to know the name of the filter you're going to filter with, so we send that as another one. I mean, you could hard code that, but we're professionals apparently. This is the autoloader part of the auto overloader. All of the hard work is still done by Composer. All we have to do is ask Composer, give us the file, and then we return a string saying, oh, actually, I want you to load this one. We've already established that we can generate code using code templates, so this would be the place to do it. If you want to generate new classes, instead of manipulating existing ones, you don't even need the filtering part. Just return it here. Return, generate, and include somehow. The overloader part of our autoloader overloader is this bit. It looks complicated, but just as we described before in less technical terms, we fetch the list of registered autoloaders and iterate over them. If we detect that one of the autoloaders is Composer, we decorate it, replace it, and then re-register each autoloader in their original order. So to make this all come to life, we load Composer, register our stream filter, and initialize our autoloader overloader. That was a lot of code to throw at you, but that's it for the main code part of the talk. And now we just carry on as normal. Any class loaded after initializing our autoloader will have its source code pass through our stream filter before being executed by PHP. There are other projects out there that implement autoloader overloading, such as IC Maxwell's generics library, and what's the other one? Can't remember. There are some of them use the eval function to evaluate the generated code, but unfortunately, this is mostly disabled on most PHP installations, so we can't really do that. Others write generated code to the disk before requiring that file. Such an example would be Symfony's dependency injection. It generates the container before you use it. But unfortunately, this won't work on read-only file systems, such as sandboxed containers where the cache is already warmed up during deployment, which is getting more and more common. So streams are perhaps the most elegant. It's built into PHP's core functionality and just works. It was added, I think, in PHP 5.0, but it was added so long ago that the documentation doesn't say when it was added. So it's that stable. Streams are also easy. And by easy, I don't mean anyone can do it. I mean, if you're into metaprogramming and manipulating your own source code, then streams are not going to be the hard part. Right. Now we know we can modify the PHP code that actually gets executed by PHP on the fly within the application that we are running, what's next? What important work can we do given all this power? Short closures, because we're too impatient for PHP 7.4. We've learned how it can be done, which you'll probably have to go through the slides again because it's a lot of code in a short space of time. But let's roll our own. Christopher Pitt's preprocessor library takes invalid code that looks like this and turns it into code like this. It's pretty unremarkable, but it demonstrates that we can transpile invalid code into something that the PHP engine can understand. Building on the knowledge that we've already gone over, implementing this is a two-step process. Include the library as a dependency, and use it in your stream filter. Remembering that this is an alias for something that's about 2 slides long, so take it with a pinch of salt. And then we're pretty much done. We've established that as long as we return a string containing valid PHP code, we can accept pretty much any input to manipulate anything, even if that input is nothing. Such as the next thing, which is obviously the most important thing that PHP has been waiting for such a long time, encrypted source code, because everyone knows that's the most important thing. This can be decrypted on the fly into something like this, which resembles some kind of normal PHP file, if you believe me. This is the main powerhouse of our stream filter. We have a fairly simple-ish stream filter method to what once was only possible using extensions. We grab the source code just like any other transformation we've done. If we don't need to decrypt it, we immediately return it untouched to be processed as it would be normally. Otherwise, if we detect it does need to be decrypted by checking the beginning of the string, which is called the preamble, which I don't know where that name came from, but it just is. And then we pass it to another function to decrypt it, which iterates over each byte and XORs it with a corresponding byte in an encryption key. This isn't government level encryption. It's going to be broken. It's meant to be simple. It also happens to be the same encryption that GitHub uses to protect their enterprise source code. Just if you ever wanted that side note. It's not meant to protect the source code. It's meant to prove intent in a court of law. So that's another thing that I learned when reading this, and also GitHub, please don't sue me. Remember, this is just an experiment. Caching the transformation result from decrypting source code would be pretty pointless if you're saving it on the same machine. Even with just-in-time compilers coming in PHP 8, this transformation or manipulating source code is never going to be fast. But that's not the point. You can do some amazing things in PHP that it was never designed to do, and probably some that you shouldn't do either. Christopher Pitt's pre-library transpiles new and non-existent language features, just like Babel.js. AOP allows you to inject logic at points in your code that it wasn't written in on the fly. Using source code transformation and autoloader overloading, you can not just manipulate existing code on the fly, but generate entirely new classes using code templates. React PHP allows you to write asynchronous code using the native stream select function, which I'm pretty sure it wasn't designed to do asynchronous code. Icicle does it with generators. There are so many projects out there that push PHP beyond the limits of what people thought was possible for the language, and the likelihood that these authors actually knew what they were doing ahead of time is not very high. Question what's possible. Experiment with ideas and have fun like you did when you first became a developer and realized the possibility of what you could do with code. You won't know what's possible until you push past the limits of the language, and just be curious. I want you to leave this room thinking that this talk wasn't long enough or I didn't go into enough detail. Go out there, look at things, read documentation and go, oh, I wonder what I can do. I touched the thing again. Create terrible things. Using Kevlin's analogy from the opening keynote, if you don't create terrible things, then the amazing things you create will just be mediocre and average. And next year, I want to come to DPC and hear people's conversations of, oh, guess what I got working? Or I can't believe that actually worked. Thank you.